Hey, how's it going, y'all? So today I wanted to talk a little bit about the different areas of physics. I wanted to kind of clear up some of the different misconceptions or mystery around some of the different parts of physics. Some parts of physics, such as quantum mechanics, has a reputation of being extremely complicated and something that's really hard to learn, but it's really within the realm of possibility for nearly everyone to learn it. I think classical mechanics was the first part of physics that was explored by scientists. What really started the modern field of physics study is really Galileo and Newton. Whenever Newton developed the Newtonian mechanics. Around the 1800s, the next large area of physics started to develop: electromagnetism. Electromagnetism was really considered to be an emerging and not a very well understood part of physics throughout most of the 1800s. And then a man called Maxwell came along and formulated Maxwell's equations, combined the phenomenon of electricity and magnetism into one phenomenon called electromagnetism. As the years passed, there was certain things that was noticed that couldn't be explained by electromagnetism or classical mechanics, such as the photovoltaic effect, the orbit of Mercury. This left a void of understanding that gave way to the development of modern physics. The first subject under the umbrella of modern physics that I wanted to talk about is special relativity, which was developed by Einstein. Special relativity can be formulated by assuming that the speed of light is the same in any reference frame. Special relativity led to a new understanding of space and time. Before the development of special relativity, time was assumed to be absolute. But special relativity shows that time can actually change depending on the reference frame that you're in. This leads to effects such as time dilation. After the development of special relativity, Einstein went on to develop the theory of general relativity, which describes the gravitational force as the bending of space-time through mass and energy. This explained the abnormalities seen in Mercury's orbit. That couldn't be explained using classical mechanics. Then as the 1920s went on, a new area of physics known as quantum mechanics started to develop. Quantum mechanics explains things that are small. Quantum mechanics was developed throughout the 1920s by scientists such as Schrödinger, Planck, Heisenberg, among others. Then after most of the fundamentals of quantum mechanics were formulated and deduced, the physics continued to develop. One of the large areas of physics that developed through the 1930s and on through the current day is quantum field theory, which explains subatomic particles as excitations in fields that permeate throughout all of space. Quantum field theory combines quantum mechanics with special relativity. So if you take the Schrödinger equation, which describes particles in quantum mechanics as waves, and you add the effects of special relativity into that, you get what is essentially quantum field theory. So basically, to summarize the differences between the different areas of physics, classical mechanics is the oldest area of physics that describes large things that we encounter typically in our daily lives. Electromagnetism explains the phenomena of electricity and magnetism that drives many of our electronic and other technological devices. Quantum mechanics explains how very small things interact in nature. Special relativity explains how things interact whenever they go at a speed comparable to the speed of light. General relativity explains the gravitational force in terms of the formation of space-time due to mass and energy. Quantum field theory combines special relativity and quantum mechanics. And finally, if you've ever heard of string theory tries to combine gravity, quantum mechanics, and special relativity. A lot of physicists are skeptical about string theory, though, because its lack of experimental predictions. It is a fascinating theory nonetheless, though. That's in large part the main areas of physics and the sequential order roughly of how they were developed. Of course, there's many other areas of physics that I haven't talked about, such as biophysics and astrophysics and lots of other areas of physics. Physics is an absolutely massive area of study. And if you enjoyed this video, please hit the like button, and if you would like to stay tuned for more videos, please consider subscribing. Thank you for your time. Thank you for watching, and have a great day.